everybody. Hey, what's up? All right, good crowd, good crowd. Hope you had a nice coffee at the break. Quick question before we all kick off. Can I have a show of hands, please? Who here has an electric car? Nice, nice, loving it, loving it. Who here has a Tesla? Oh, hard luck, guys, sorry. All right, no, just kidding, just kidding. We love all electric cars the same here. Yeah, listen, guys, so I'm gonna go through a couple of things today. I have brought this out with the premise of building your own electric vehicle charging map using PostGIS and other open source software. I will make a little disclaimer here, which is to say that I am not saying throw away your Google Maps, do all your routing yourself, build yourself a cloud at home, get all your services. I'm not saying this at all. What I'm doing here is showing you the power of Postgres, PostGIS, and all the open source software in the ecosystem around it through a real world use case. So I'm going to crack on into it pretty quickly. This is, yeah, an introduction to me. You already heard a little bit more about me, so I'm not going to labour the point. But here's, some interesting facts about me, my large vegetable garden, my massive Lego builds, and my interest in powerlifting are my interesting facts I normally put out there. So that's something for you guys. I do work at EDB, very excited to sponsor these conference events, really, really cool initiative. We are the largest contributor to the Postgres project. We are the largest Postgres company globally. If you need any Postgres, give me a shout, I'll hook you up. So I'm gonna start by just doing a little tiny bit of information. I know there's probably a lot of different levels of knowledge around Postgres and around spatial data in the audience. I'm just going to point out a couple things. Development crowd, I would be hoping most people at this point would have heard of Postgres. If not, it is the world's most advanced open source database. Don't listen to any other people on that one. But we do. So one of the things that makes it the world's most advanced open source database is its extensibility, its flexibility in terms of being able to design your own systems using Postgres. So you've got user-defined data types, user-defined indexes. And this is why when those guys over in Canada, whose name escapes me right now, initially built the Postgres extension over 20 years ago, they went with Postgres because it was the only system that was powerful enough to build something like this. So a little bit about PostGIS. I already said, been around for 20 years now. It's very, very mature software. PostGIS in actual fact probably kept people coming to Postgres during the years when, we were struggling against Oracle for the performance points. PostGIS kept people interested. And the reason is that it is far and away one of the most powerful spatial data systems you will ever come across. And this is why, it's got such huge use in commercial and enterprise contexts, as well as being, an open source project that so many people are really, really passionate about. One more little thing before we get into the details, a little bit about OpenStreetMap. Not sure how many people are familiar with OpenStreetMap. It's a community mapping data project. It's absolutely massive these days. So users of OpenStreetMap include Facebook, include Apple, include Tesla. Hey, so you see where we're going with that one? But yeah, I don't know if you've ever played Pokemon Go or any other Niantic augmented reality games. That is all based on OpenStreetMap as well. So this is really, really solid stuff we're working with. Just a little point on the side there, just a few data types that we'll be working with OSM today. So nodes, ways, relations, and tags. And this is just to kind of get your head into thinking about spatial data types. Nodes being, locations and points. Ways being, line strings or strings between points, lines that connect different points. And then, of course, metadata that goes around that. But just a few things to kind of keep in mind as we go through this. So in terms of setting up a tile server, we've called it a map server, we're going to call it a tile server because that's really what it is. We're serving up tiles. This is obviously, you know, we're not going to go through all of this right now. That would be crazy. But what we're trying to highlight here is you can see on the left-hand side there, we've got a stack of very, very available open source software. And what are we going to try and do with that? So the really amazing thing about a lot of this is that all of this mapping data lives in Postgres with the PostGIS extension. And I'll just briefly flick over to my other. We're gonna have some interesting points today because my VPN appears to have conked out just literally 5 seconds before we started here. But this is my live map that's running off my Postgres server with the PostGIS extension, and all of this data is it's all in Postgres using PostGIS. So, you know, it's really, I think it's really quite remarkable that, you know, all of this is being queried straight from PostGIS. And if we go back to my slides there. So what are we trying to do when we're setting up a tile server? What do we need? We need the data that we're storing in PostGIS, and we need to render that data, get that through our web server, get that onto our web browser, get it open so people can see it. And then we've got a JavaScript layer that we put in front of that so we can put on our interactive data and show, in this case, it's going to be our electric vehicle charging stations. So again, this is all super, super easy stuff. This is all open source software, very easy to get hold of, barely an inconvenience. And we're going to crack on through and show some stuff that we're going to do using this stack. So this is quite useful because I have my screenshots here, just in case my VPN did conk out, which is good. So we've got that good to go. As I said, this is the map data. I've just shown you that on the live browser. That's all running directly off PostGIS. So we can put in a simple little marker for home. So we use the leaflet JavaScript tool that's built on top of the map server, and we can just. So I'm just going to show you guys a little bit here. So we're still not connected there. But this is my HTML file that sits behind what you can see being served up on that web page there. So you can see down here we've just got. Obviously, I can't actually navigate this file now. I'm not actually connected to my kit anymore. But you can see in there there's a marker file, and that basically, as you can see from the screenshot, shows the marker on the screen there. So in terms of how we're going to set this up, so I'm just going to show how easy this is. So importing electric vehicle charging station data to Postgres, we're using data from Transport for New South Wales. We're going for Sydney here. This comes as CSV data, and we're basically just going to store it in our PostGIS database. It comes as coordinates. It's probably worth pointing out here, coordinates by themselves do not actually constitute a spatial data type. Because there are different spatial reference systems, and if you're using Euclidean geometry or using Cartesian planes and so on, there are lots of different ways of looking at things, so not all coordinates are created equally, shall we say. So one of the things that PostGIS is really good at is taking your coordinate data and transforming it into the spatial data types that you need to do your calculations with. So if we click through here, all we're doing, super simple, we're just going to create a table, we're going to import our coordinate data into that table, and our PostGIS function is going to transform our coordinate data straight to spatial type point data, and you can see there underneath that's now existing as spatial data. That's the point data that you can see on the side there with the geom type. Super easy, PostGIS will do all of that for you. Now you've got that charging station data in your database. We're going to need to get it out again, because of course that's the way these things work. One of the really cool things about PostGIS is you can convert any spatial data through to GeoJSON. GeoJSON is a very widely supported format. We're going to use it in our leaflet JavaScript. But look, that is super, super easy to use. Again, you've just got a function, put your data in there, translate that into GeoJSON, and that goes straight into your HTML file in my case. I'm not going to go through this function. Obviously, this is a giant stored procedure. So what I've done here is I've passed the stored procedure a polygon, which I've drawn out, and all I'm trying to do here is say, give me all of the charging stations that are within this polygon. So this is a stored procedure that will do that for you, and then it will also spit those stations back out as GeoJSON data. So again, really, really simple, really useful. All these functions are built into PostGIS. Off you go, really, really good. So I'll show you guys, so this is just an excerpt of the GeoJSON data that it spits out. You can see all the tags are in there, coordinates are back in there, all of your metadata's in there, so you know you can have that interactively on your map if you like. I'm going to go through here and show you guys that my VPN is unfortunately still not working. We'll give that one more try because it would be nice to do a little bit of a live one there. No, we're definitely having some quite significant issues there, but that's not a problem. We'll crack on through. So as I say, we're going to stick that GeoJSON data straight into our HTML file. Obviously, I can't really show you that now because I can't connect directly to the server, but this is what it looks like. And we've just got our lovely JavaScript layer on top of our map, which is now displaying all of our charging stations. So fantastic. Again, super easy to do. So other things you might want to do with an electric vehicle charging map. What are the things that you want to do with that? You want to know from your home base, you want to say how many stations within the range of my car. So say I've got 60 kilometers left, you want to say how many of those stations are within 60 kilometers, can you give me the details? And you might want to know the nearest one as well, because you know we've only got 60 kilometers left. You know, solar panels have not been putting out a lot of energy today, unfortunately. So we've can't get a charge at home. It's raining again in Sydney. So let's have a look. So this is another PostGIS function. In this case, we give it a starting point, and we are asking which of these charging stations we have are within 60 kilometers of our home base. And again, it's just very simple. You pass it your coordinate data, this time of your home base. Is it within, they take the number of meters, that's why that says 60,000 there. Is it within 60 kilometers? And it spits out, this again is the station data. So you remember before, we take our spatial data type, put it through the GeoJSON function, and then again, we can stick that straight into the JavaScript layer and they just come up on the map. So that's super easy. This again, another really useful function. This time we're gonna spit out the same data, but we're gonna have it ordered in distance of kilometers. So PostGIS is just gonna do that measurement for us. And show us the nearest charging stations. Now at this point, you'd be well within your rights to say, well, Lizzie, hang on a second, is that routing data? What's going on there? Is that as the crow flies? And I would have to say, yes, that's as the crow flies. I've got an electric crow. Not actually the case. This is just that we're going to show the basics of what's going on here before we get into the routing stuff. So again, super simple. This is how far our charging stations are away. These are the functions we're using to do that. Now we're going to get onto how to do the routing part. So I was saying before about Postgres and PostGIS being this fantastic open source ecosystem. Part of that is the pgRouting extension. So in terms of spatial data, when you're looking at calculating routing data, what you need to do is you have to have what we call a network topology on top of your mapping data. And that sounds very fancy. But what that really means is we want to take the points that are on your map. We have lines which are between points on your map, and we put them together to create nodes and edges in a format that you're probably familiar with if you've used graph databases at all. So what pgRouting does for us, and this is just so fantastic, pgRouting, you can install that on top of a PostGIS database using OpenStreetMap data. which we'll do in a second, you can use a tool called OSM to pgRouting, and that will create you, and this is totally hands-off, that will create you a network topology in your database on top of your map. So this is very, very cool. This is some data. This is, I can provide slides afterwards to anybody who's interested, but these are some steps that you would go through to do that work. So in terms of how this actually works in your queries, and this is where it gets quite interesting. So, at least interesting for me. So what pgRouting will do is it'll go and it'll create tables within your Postgres database that effectively have the details of every single possible node and edge within the entire map of the data that you've given it. So this is an example of a table, a record from the table that includes all of the vertices that it's calculated from that data. So not only does you can see in there, it's got like the source coordinates, it's got the target coordinates, it's also got cost data in there, and it's also got length data in there as well. All of this stuff together, there's also various contextual data around one ways and max speed and that kind of thing, which is also very cool. But what this cost data and length data allows you to do is use algorithms that are written into pgRouting. So Dijkstra's algorithm, a lot of you might be quite familiar with. There are plenty of other ones written into pgRouting as well. But you can then use these algorithms and this costing data, this length data, to basically come up with the most optimal route from one place to another. This is a very, very classic computer science problem. We've all heard of the traveling salesman problem, right? All of this stuff is written into pgRouting, completely open source extension for Postgres. So we're going to go through here. So what we're going to do, which again is a little bit limited given I can't access my server, I have got screenshots. So what we're going to do here is we're going to calculate a route between our home base, where our poor electric car is sitting unable to get any energy from our solar panels. We're going to go from our home base to our nearest charging station, which is down the road at Chatswood. So what we can do, take those two coordinates. Again, you don't even need the spatial data type. You can just put the coordinates into the PostGIS functions. We're going to put that into the Dijkstra function, and that's going to give us a route, which is going to be a list of all of the points between down the nodes, all of the nodes, the edges, the nodes, the edges, the nodes, the edges, in a complete sequence, and it's going to give us a route, the best route, to our charging station. So once you've got that data, obviously we're going to, again, if we want to represent it on the map, we're going to need to translate it into GeoJSON again. Hooray! We already know how to do that, so that's fantastic. So let's have a little look at the data and see what that looks like. This is the Dijkstra function. Again, this isn't the Dijkstra function, I should say, sorry. This is my query that calls the Dijkstra function. So as I said before, all you need to do in there, all you're really putting in there is the coordinates. And it's really, really, really that simple. I have put a note at the bottom here, which I don't know if you see, this query drives the car through a few parks and a few walking tracks. Which is strictly speaking true. It gets a little more complicated. There are different routing options in pgRouting for walking, for cycling, for driving. That's another layer of complexity that I didn't want to bring into this. So if you see the car going through a park, just pretend it's like an electric bike or something. It's fine, don't worry. All right, guys, so what are we going to do with this? So let me see if I've got my if we've got an example of the data. Oh, it's a little bit unfortunate. I haven't got an output of the data. That's okay. So basically what this query is going to do is it's going to call that function, and it is going to output all of that data, so all of that line string data that I mentioned, all the nodes, the edges, straight into its own table. Copy that over to a file, anything you like, stick that through the GeoJSON converter again, and we've got something completely ready-made to go into our leaflet JavaScript. So we can see here, so this is what the data looks like when it comes out. You've got the line string, you've got the coordinates, you've got the source and the target, and that goes all the way through each one of those individual lines and creates an entire route for you. So again, this is all native to PostGIS and pgRouting. There's no need for any other software, anything on top of this. This is all native stuff that's built directly in. So this is what it looks like when you get it on the map. Wish I could have done the live example. Very, very devastated about that, but not to worry. So yeah, this is what it looks like. As I said, you are going through a park, which is a bit unfortunate. But this is the route, and you can see it's basically taken all of those individual node and edge calculations, and it's put them all together for you, and it's given you the most optimal route according to its opinion. And we can map that straight directly onto the map there. So that's fantastic. Couple things I just wanted to also mention about PostGIS before we finish here. I know I've just kind of scratched the surface here. So these are just a couple more things. Yeah, look, PostGIS is really, it's really good at integrating with other systems requiring mapping functions. So, there's full support for KML, full support for MVT. We did some GeoJSON today, which is a very, very well supported form of spatial data. And this allows, so what this is this means that your applications can talk directly to Postgres with the PostGIS extension without having to have sort of, translation layers in between or having, any further sort of middleware in there that's going to, further bloat your stack, introducing, overhead and complexity and so on. PostGIS is really, really fantastic for that. You plug straight in and off you go. In terms of data types, so we only touched briefly on geometry and geography data types today. The other quite nice thing about it is there's full support for 3D, which is very, very cool. And also, some people kind of raise their eyebrows when I say this is also full support for 4D data types. Which is not time as the fourth dimension. This is actually user-defined dimensions. So any other measurements that you want to put in there in terms of, some people have sort of depth of sort of ground layer stuff, things like that. There's all sorts of other data that you can put in there, and it's completely customizable. So that's really fantastic as well. Again, as I was saying earlier, it's all about, the power of using the power of Postgres for user-defined data types and flexibility. Very, very quickly, could also work simultaneously with vectors and rasters, which is very, very useful functionality, and it also converts very easily between the two. I haven't touched today on spatial indexing in Postgres, which is also very, very exciting, bounding boxes and R trees go all the way down. They have this sort of self-tuning capacity, which is really, really interesting. And I think the last thing I want to point out is, again, this is all on Postgres. No need for any other software, completely open source. You can build all of this yourself. It's available right now, super performant. You don't even need a ton of resource. And yeah, if you haven't had a go, I would definitely encourage you to crack on and have a play with PostGIS. So yeah, that's about all I've got for you guys today. I'm really, really sorry about the demo and the map server. That's really, really unfortunate. That's been working. I'll give it one more. Yeah, that's not gonna do anything. That's really unfortunate. Yeah, so unfortunately that'll have to be it. Any questions? I have a couple of questions here. Sorry, yes.
How fast is the? How fast is that? Is that a couple of minutes, or is that a split second?
No, so one of the really nice, thank you for one of the really nice things about it is that it builds all of that in advance, and it's all indexed automatically as well with the pgRouting OSM to pgRouting layer. So all of that, the routing comes back really, really, really quickly. It's very, very performant, and even though it's searching across a massive data set. Yes, another question. Thank you.
Yeah, I just had a question. Is there room to like add more information? Like if you had information about which roads are toll roads, or like the number of people at the charging stations?
Yeah, absolutely. So you can definitely, with OpenStreetMap, the way that the relations work, you can put metadata into the tags. It's all key value pairs. And with something like the charging stations, you could pull that data in on a pull basis that would do that automatically and update that. You could do that with an interactive layer, absolutely. But yeah, all of the metadata is stored in tags that are against relations, and they're really extensive. So they're definitely very customizable. You can put all that data in there.
So with this PostGIS plugin, you said the data itself will come. So is there any room for extension, like if I have a university map, to make custom maps and then use those algorithms that is already present in there? So.
Yeah, interesting. That's a really good point. So if you already have algorithms that work with spatial data, you can certainly use PostGIS as a data source for that. You just have to watch out for things like what spatial reference system you're using, and make sure you're using the same one across your algorithms as to the data that's stored natively in PostGIS. Yes. Sorry, I thought somebody said something. Yeah, but no, that's absolutely possible. I'd be really happy to talk to you about that after the session as well. Thank you. Cool, good to go. Alrighty, well, thanks for listening, everyone. Cheers.